Okay, we took a little break there, and now we're back at 11 now. It says determine whether 9x squared minus 5 and y squared 3 plus 3y minus 2 over y are monomials, binomials, trinomials, or none of these. All right, so let's take a look. And, the first guy over here, clearly it's a polynomial. And, certainly when I say polynomial, it's a binomial. All right? Now, someone says, how do you know it's a polynomial? The terms are monomial, and the dead giveaway is over here is the exponent has to be a positive integer. And someone's going to say, how about the second guy? Well, the second guy, you might say, oh, it's a trinomial, but there's a problem because 2 over y is actually 2y to the minus 1. And the exponent's a negative integer, so it can't be a polynomial. So it's none of the above. All right? None of these. All right, let's go to the next one. This is a factorization problem. And, for the most part, factorizations, they can be easy. They can also be maddeningly difficult. But I'm noticing over here that it looks like the only factor common to all three terms, which is called the greatest common factor, is a factor a and b. There's two factors, a and b are common. You left off with 2a minus 5ab, I'll check it in a moment, and plus 7b. All right, let me just check it. I would give you 2a squared b, that looks good, minus 5a squared b squared, that looks good, and then you get plus 7ab squared. Looks great, and that's the answer that's being listed over here. Let's go to the next one. Let me make sure I get the answer listed correctly. Yep. This one looks like we're factoring my grouping. I want to remind you what that means to me. I'll take the first two terms and then the second two terms. Let's just do the first two. There's a GCF common to those, and that's going to be x. We're left off with 2x minus 5 minus, well, what's common to those two terms? It looks like 3y. What are you left off with? Looks like 2x. That would give you minus 6xy minus, well, let's see, that'll be 5, right? Let's see what you get. 2x minus 5 is a factor common to those two terms. What's left over? The factor x, and then the factor minus 3y. That answer right over here. All right, 2x minus 5, x minus 3y. This one over here, factor it. I'm going to assume it's factorable by trying. That can be maddening at times because if something doesn't work, you're never going to get it. And I'm looking at 36, and I'm going to say 9 and 4. Plus 9 minus 4. Does that work? You get x squared. 9 minus 4 is 5x. Yeah, it works good. Check the key. All right, looks good. Now, I think D might be a little bit unfair at this stage of the game because no matter what you do, you're not going to get it. What I mean by that, you're not going to get it if you use integers. There are numbers that will let that factor, but right now we don't know about those numbers, so I'm going to say it's not factorable. Now, letter A, it's a difference of perfect squares. That's 4 minus 3m and 4 plus 3m. All right, got that one done. Oh, let's see. Greatest common factor over here, it looks like 2, and then x squared. What we left off with? 2x squared minus 19x plus 24. Now, granted, that could be the end of it, but I'm going to say there's a quadratic there, and there's a good chance we can factor that. I'm going to say 2x and x would be 2x squared. I'm going to say 8 and 3. Minus 8 plus 3. Let's just check it. That gives me 2x squared. Let's see, minus 16. Whoops, made a mistake. Got to correct it. Just noticed it. So I'm checking it. That's why I noticed it, by the way. 2x times x is 2x squared. Minus 16 minus 3 is minus 19. And you do get plus 24. Let's look at the key. Make sure the key says that. I see the 2x squared. I see the 2x minus 3, x minus 8. Things are working out pretty nice. All right, this one's a solve type problem. Well, add 2x to both sides and subtract 15. And what does that give me? That gives me minus 12 equals 6x. And now divide both sides by 6. And what did you get? X equals minus 2. All right. This one's a fraction. I would multiply both sides by the LCD. The LCD is 12. And that's like multiplying every term by the LCD. So you get 12x. And 12 times 2/3 is going to be 8. And 12 times 3/4 is 9. What do you get there? 12x. I'm going to subtract 8 from both sides. You get 1. And then I'll divide both sides by 12. You get 1/12. All right, let's take a look at this one over here. Again, what I do is I'd multiply both sides by the LCD, which is 5. So we get minus 3x. And 5 times 12 is 60. Then I would divide both sides by minus 3. And you get x equals minus 20. Relatively straightforward. This over here, multiply both sides by the LCD, and you get a very simple answer, which is 3.2 times 1.46. I don't want to bore you with the details, but you should multiply that out, and that would give you 4.672. I have no objection to showing you how to do that arithmetic, by the way. I would never tell a student I won't do that for them. If you want me to do it, I'll do it for you. All right, but that's the answer. That's what we're getting over here. All right, this one over here, it's an LCD problem, and what I mean by that, I need the least common denominator, and that would be 12. And I would multiply both sides by 12. You'd get 6 minus 8x equals 3. I would subtract 6 from both sides. You get minus 8x equals minus 3. And then I would divide, oops, sorry about that. And then I would divide both sides by minus 8, and you get 3/8. Whoops. Okay. Simplify each side. You get 9x minus 6x plus 3 equals 15. 9x minus 6x is 3x plus 3 equals 15. Take 3 from both sides. You get 12. And divide both sides by 3, you get 4. Now, certainly it's really easy to make mistakes, and that's why we'd like to give you an answer key. You can check it, but you should also consider checking these things in the original problem. Let's put this one down. It's going to be called the zero product rule of factoring. I'm certainly going to factor it, and I'll use the zero product rule. And let's see. It looks like 5 and 3, minus, minus. And the solutions of this would be x equals 3. That's where it becomes 0, or x is equal to 5. There's 2 solutions to the problem, 3 or 5. This one here, very similar. Simplify. Get a 0. Factor, if you can. That's an equal. I'm going to say 12 and 1. Looks like minus 12 plus 1. And what are the answers to that? X equals, well, when does x plus 1 equal 0? At x equals minus 1. Or when does x minus 12 equal to 0? When x is equal to 12. Let's keep going. This one over here, got to multiply it out. And if I did that, what do you get? X squared. Let's see, 4 and 3 is 7x plus 12 equals 72. I got to get the 0, x squared plus 7x minus 60. I took 72 from both sides. Now, granted, I don't think they're terribly big numbers, but you might struggle with this. I hope you don't struggle too much. And I'm kind of looking at it, I can say 12 and 5. Plus 12 minus 5. Let's see if that works. You get x squared. Let's see, 12 minus 5 is 7 like we want it to be. And minus 5 times 12 is 60. So the solution is going to be x equals 5 because x minus 5 becomes 0 when x is 5, or the second factor becomes 0 when x is minus 12. These numbers can be checked with a key. They can also be checked with the original expression if you like. This one over here, multiply both sides by the LCD. The LCD is x plus 3, x minus 1. And if you did that, you would get 5 times x minus 1 equals 3 times x plus 3. Some students call this cross-multiplying. This is going to be 5x minus 5, and that's going to be 3x plus 9. What I would do now is I'd probably subtract 3x from both sides and add 5, and you would get 2x equals 14, or x is equal to 7. All right, this one over here, multiply both sides by the LCD, which is very simple, just x minus 3. And what do you get? 2 times x minus 3 plus 3 equals x. What do you get here? 2x minus 6 plus 3 equals x. What do you get over here? 2x minus 3 equals x. Well, if you simplify that, not simplify, but if you solve for x, what do you get? X equals 3. Now, granted, I realize some students say, oh, that's the answer. Unfortunately, it's not the answer, and I'll tell you why. You can't divide by 0, and that would produce a division by 0. So I'm going to say there's no solution to the problem. All right? All right. Oh, and it even says that. All right, that's good. It may not be obvious, but the original statement is a contradiction and can never be true. All right, this one's solved for S. And, certainly sort of looking at this looks more complicated, but multiply both sides by the LCD, which is T. And what do you get? RT equals C minus S. Well, I'm going to add S to both sides and subtract RT from both sides. And that's what I get, and that's what they got. S equals C minus RT. This one over here, a little more complicated. I'm going to say factor out the letter P. That's a factor now. And what do you get? 1 plus RT. And now divide both sides by P's coefficient. And what do you get? Well, P's coefficient is just simply 1 plus RT. And then you get P. All right? That answer is written right over here for you. All right? These are, simple word equations. It says, what is 35%? That means 35 over 100 of 80. Well, I'm going to, do the arithmetic now for you. So I'm going to reduce it. I'm going to divide by 10. That would be 8. That would be 10. I'm going to divide by 5 now. Well, 5 goes into 10 2 times, and it goes into 35 7 times. I'm going to divide by 2 now. 2 goes into 2 once, goes into 4 times. What do you get? 28. That's the what. Okay, what percent, let's write this down. What percent of 20 is 16? Well, let me reduce this. What do you get? X over 5. Why is that? 20 goes into 20 once, but it goes into 105 times, is equal to 16. Multiply both sides by 5, and 5 times 16 is 80. Right, so what's the answer going to be? It's 80%. All right, let's keep going. And this one says 3 is 1.5% of what? I don't know. Let's take a look at it. Probably multiply both sides by 100, and you would get 300 equals 1.5x, and then I would divide both sides by 1.5. You get x on the right side, and 1.5 goes into 200 times. What's the number? 200. All right, this one, a little tricky because they say, if something's true, evaluate something else. Well, 4 minus 5x equals minus 1. That's minus 5x equals minus 5. And that means x equals 1. So I'm going to take this 1 and plug it in up here. And what would they give you? 1 minus 3 plus 1, which would be, let's see, 1 minus 3 is minus 2. Minus 2 plus 1 is going to be minus 1. I see that. All right, this one over here says, is it a solution to the problem? And this is an ordered pair of numbers. So x equals minus 5. Let me write this down for you. Again, where's this coming from? It's coming from reading. All right, so x is minus 5. And what's y? Y is 3. And I'm going to plug it in here and see if it's true. Well, what's 3 times minus 5? That's minus 15. And minus 2 times y would be minus 6. Now, that's clearly not equal to what they say it is, which is 9. It's minus 21. So that's not equal to 9. So the answer is no. All right? So this one says determine the x and y intercepts of this equation here. It's a fairly straightforward equation, by the way. And the way to do that, to get an x-intercept, all you have to do is set the y to be 0. And if you did that, what would you get? You would get 2x equals 12. Well, that means x is 6. Now, to get a y-intercept, what you do is you set x to be 0. Well, if x is 0, what do you get? Minus 3y is equal to 12. And what's it going to give? Minus 4. Right? These answers are listed for you. but they go on to say they also want to know the slope. And what slope? It's really the delta y over the delta x. All right? And you may want to write this as y2 minus y1 over x2 minus x1. Well, let's do it. The change in y is minus 4 minus 0. I want to point out what I'm doing over. I'm doing this over here. And then what do you get on bottom? You get 0 minus 6. Whoops. You get 0 minus 6. What does this give you? M is equal to minus 4 over minus 6, which is just 2/3. And is that listed for us? Yeah. And they even give you the formula here for you, all right? So let's say determine the equation of a line that satisfies the given conditions. You know, I'm going to put out an equation of a line as y equals mx plus b, or if you prefer, y minus y1 equals m x minus x1. All right? Now I'm gonna do that. I'm gonna call this thing y1, and I'm gonna call this, I'm sorry, I made a mistake there. I'm gonna call this x1, and I'm gonna call this y1. And this, of course, is m. Let's write it down. So y minus y1, that's y plus 3, equals m, which is minus 1/2, times x minus x1, which is 2. What do you get over here? Y plus 3 equals minus 1/2 plus 1. And I don't want to keep writing that down. What do you get? Y equals minus 1/2 of an x. And what do you get over there? Take 3 from both sides, you get minus 2. So this is a good answer for the students that like this form. And this is a good answer for the students that like this form. All right? We got this form written over here for you, and we also have this one over here. By the way, don't worry about the standard form, but some students like to write a standard form down. Don't worry about it if you don't want to do that. It's really not an important form at this stage of the game. But that form would be x plus 2y equals minus 4. All right, this one over here, find equation of a line, fairly simple. I got to get slope first. Change in the y's, that's going to be 0 minus 6, over the change in x, 2 minus 0. That's minus 6 over 2, which is minus 3. And pick any point you want. I'll pick this one over here. So y minus 6 equals minus 3, x minus 0. And what does this give you? Y equals minus 3x plus 6. Again, it seems like most students actually prefer that form. That's written over here. I also have this one written down. Now, if you use the other point, you get this one over here. And if you want standard form down, that would be standard form. This is a translation. And, translations can be difficult, by the way. You're taking words and writing down the algebra. And what does letter A say? It says the product of t, that means t is a product with something, and the sum of t and 16. That's the translation. That's that right there. They also want you to simplify it. This would be t squared plus 16t. That's a simplification. That's right here. Let's do the next one. This one says r decreased by. So r decreased by the quotient of r and 3. This is the translation. The simplification is fairly simple, by the way. And how do you do that? You'd have to add those two terms together. 3. This should be 3r minus 1r, which should be 2r over 3. That would be a simplified form of it. Both answers are given, by the way. What is this one over here? It says 9 less than the total. Total means I'm adding things together. The total of a number. I'll say the number's n, and then 2. That's the translation. Now let's do the simplification. What do you get? N minus 7. Let's do the next one. Twice. That means 2 times something. The difference, that means there's a subtraction. 6 times a number, and 7. And what does that give you? 12n minus 14. That's done. All right, let's keep going. Translate each of the following sentences to an algebraic equation and solve to determine the numbers. Algebra must be used. I want to point out, they say equations. So that's what we're looking for. These are now equations. They're not just simply statements. These are equations. What's the equation going to be? The difference between 5 and twice a number is 1. So I translated it into an equation, and I'm going to solve it. What do you get? 4 equals 2n, or n is equal to 2. All right, so the next one. And what does it say? 4 less, that means I'm taking 4 from something, then 3 times a number is minus 25. Whoops, I don't know why I put that 27 there. It's not right. Got to erase that. Minus 25. What are you going to do? I'm going to add 4 to both sides, and what do you get? You get 3. By the way, I just translated a sentence into an equation. That's right here. We're going to solve it now. What do you get? 3n is minus 21. I added 4 to both sides, and n would be minus 7. All right. Okay, these are more difficult, by the way. I want to point out why they're more difficult. There's 2 things now. They say the sum of 2 numbers is 18, but then they use words like smaller and larger. So I'm going to say smaller number, larger number. What do I know about these things over here? That if I add these 2 numbers together, I would get 18, like they said. Now, I'm going to say the larger number is simply just 18 minus s. So what I want to do is I want to read it again with the understanding that the small number is s and the large number is just 18 minus s. What does it say? It says the total, which means I'm adding things together, of 3 times the smaller and twice the larger. What's the larger? Well, it's 18 minus s. And then they say it's 44. And this is the translation, and that's written there. Now I'm going to do the next step, which is, trying to solve for s and l, but I got to get s first before I can get l. That's going to be 36 minus 2s equals 44. Well, 3s minus 2s is just s, so s plus 36 equals 44. And that looks relatively simple to do. S is going to be 8. Well, if the small number is 8, what's the large number? 10. How do I do that? Plug it in right over there. So what are the 2 numbers? 8 and 10. All right? Now, these are consecutive even integers. Now, it's an integer. If x is an integer, the next integer would be x plus 1. Now, if x is an even integer, the next even integer would just be 2 up. Now, what do they say? Find 2 consecutive integers such that 4 times the first, is, 3 times the second, which is 3 times the second, which second is x plus 2. What do I get over here? I get 4x equals 3x plus 6. X is 6. Clearly an even integer. What are the integers going to be? 6 and 8. And that's the equation that we got over there. Notice I used x for the integer. They're using n. The sum of 2 numbers is 6. The sum of the square of the 2 numbers is 20. Well, you know what? This is not like a small number, large number, but I'm going to say one of the numbers is x, and the other number is, well, if they add up to 6. If they add up to 6, what's the other number going to be? 6 minus s. Now, what did they say? The sum of their squares. The sum of their squares of these 2 numbers is 20. I got an equation to solve. What do you get? X squared plus, well, what's 6 squared? 36. Then you're going to get, 6 and 6 is 12, plus x squared equals 20. Well, you get 2x squared. Minus 12x. And looks like plus 16, right? Again, I want to point out this is the equation. This equation is written over here. They use n instead of x. Let me see if I can solve that. I'll divide by 2. And what do you get? X squared minus 6x plus 8 equals 0. I got to factor that, don't I? What do you get? X and x. And I'm going to say 4 and 2. X could be 4. X could be 2. Now, what's nice about that? If x is 4, and again, we're looking at the relationship, the other number would be 2. And if x was 2, the other number would be 4. So there's only 2 numbers. And what are those 2 numbers going to be? 4 and 2 would only satisfy that. All right, number 21, a little more complicated. A lot to read. It says, in a high temperature 6-day period. Oops, sorry about that. 6-day period. There's 6 days. They measured the temperatures to be these things. right? And there's six measures there. Where they want to calculate the average. How do you do that? Just add all those temperatures together and divide by 6. I'm not going to bore you with the details, but you should be able to do that. And again, if there's ever disagreement about what I'm telling you, you know what? Bring it to my attention. Say, you know what? I think I made a mistake with problem number 24, and I'll take a look at it, right? I'll correct it, and I'll give you credit if I make a mistake. Or I'm going to say take a little break here, and we'll come back and finish up the sheet in a bit.